Hello everyone. In this chapter, which is chapter 16, we're going to be learning about reactions of aldehydes and ketones. And in this chapter, it says is one of the compounds found in group 3. So in the group 3, meaning that you have a carbonyl group, and one of the families, a carbonyl group, can attach to an atom Z, which is going to be more electronegative than carbon. For example, we can consider that as when the carbonyl group attached to oxygen. It could be as an acid group like that, alcohol, that makes it an acid, or it could be an ester, or it could be a carbonyl group attached to another electronegative like chlorine. So we call this as a acyl group. That's one category. And then also you can have a carbonyl group attached to another group. In this case, it could be another alkyl group or hydrogen. And this is what we are going to focus in this chapter. So they are under the category of aldehydes and ketones. The very basic aldehyde is the formaldehyde, where you have a carbonyl group. In the both sides of the carbon you have hydrogens. That is the very basic aldehyde, formaldehyde, with one carbon. Now how do we represent an aldehyde? Again, both aldehyde and ketone has a carbonyl compound, and then you will have alkyl group on an aldehyde, and then the other one is going to be a hydrogen. In a ketone, the both sides of the carbon will have alkyl groups. That's the difference between aldehyde and the ketone. Formaldehyde has two hydrogens. Aldehyde has a one hydrogen and an alkyl group, one hydrogen alkyl. Ketone has two alkyl groups. So you will know that aldehyde will always be a terminal carbon, whereas a ketone can be a middle one. Okay, if aldehyde happen to be in the middle, you don't call it as aldehyde, that would be a ketone. Okay, so these are some aldehydes and ketones found in nature. It's good to know that these compounds are in nature so that we have more curiosity and more interest to know about these compounds. So this is vanillin. What do we have in vanillin? We all know about vanilla. We eat vanilla wafers, cookies, ice cream, right? Vanilla used in baking and making compounds like in the kitchen, right? So vanillin is a flavor, vanilla flavoring. So this is the actual active molecule, active ingredient in vanillin. This is your carbonyl group. What is this? Is it aldehyde or a ketone? This is a carbon, this is a carbon. So this is a ketone. In addition to that, you have an alcohol functional group and an ether functional group. And this one is a cinnamon flavoring. Some of you love to eat cinnamon, flavored buns and then tea. And, we can make lots of other stuff with cinnamon. Churros, I think I pronounce it correct. Anyway, cinnamaldehyde. So this is what you find as a cinnamon flavoring ingredient. What do we have in cinnamaldehyde? Aldehyde or a ketone? You have hydrogen on the one side of the carbonyl, the other side the alkyl group. So it's an aldehyde. Even the name says it's a cinnamaldehyde. And then camphor. Camphor, we have ketone in camphor. And then we have spearmint oil. We find this in spearmint. In spearmint oil also we have a ketone. And these are pair of enantiomers. Okay, and this is caraway seed oil. So this is the minus carbon plus carbon, R and S enantiomers, spearmint oil and caraway seed oil. The difference is only this chiral center, but both of them have ketones. Aldehydes have pungent odors, ketones have sweet odors. Vanillin is a sweet odor. Even cinnamaldehyde, it's not that bad, right? It's okay. Okay, so these are some biologically important ketones. So this is progesterone. You have heard these names, and this is testosterone. Both of them have ketones. Here's a one ketone, here's a one ketone. And the structures of progesterone and testosterone pretty much the same, right? Carbonyl group, alkene, a methyl, hydrogen facing up, facing down, methyl. What's the only difference between these two? Here you have a ketone in the progesterone, ketone and the methyl group, and instead here you have an alcohol group. They have different functions, progesterone and testosterone. They are biologically important ketones. And let's learn how to name the aldehydes. Okay, there are two ways. One is a systematic name, and then the other one is the common name. Common name used for the molecules that we very often use. For example, formaldehyde. Formaldehyde is known by many people, but sometimes even the chemist, non-chemist would also know about the formaldehyde, but they might not know the systematic name. So this is formaldehyde, but the systematic name is methanol. Aldehyde ends in L because it's an aldehyde, L. And then the prior to that comes methane, because for one carbon, remember the nomenclature when you were in organic 1, for one carbon it's methane, two carbons ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Like that, if you have one carbon, methanol. So two carbons, 1, 2, this is aldehyde, ends in L. Two carbons, ethanol, and then this is called acetaldehyde. Okay. And then if you have a substituent on the alkyl group, we can number them from giving priority to the aldehyde group 1, 2, 3. So in the second position you have a bromo group, so that would be 2 bromo, and then there are 3 carbon atoms in the main chain, so that's going to be propane, so it's going to be 2 bromo propanol. That's a systematic name. And then since it's an aldehyde, you can call as a common name alpha bromo propionaldehyde. Alpha bromo propionaldehyde. Normally you will see sometimes we use alpha beta nomenclature, not the nomenclature, I mean classification for carbons. Normally alpha is given. Now let's say this is the carbonyl group of interest, and then the carbon next to the functional group of interest is named as alpha carbon. So this is called alpha carbon, meaning the first carbon from the functional group. Alpha beta, so this is called alpha, so alpha bromo, you have a bromo group, propionaldehyde. That's the common name. And then this one, let's see how many carbons are there. We have 1, 2, 3, 4. So on the third carbon we have a chloro group, and then the main chain has 4 carbons. So how would you name it? And this is an aldehyde, should end in L, so that would be 3-chlorobutanol. 3-chlorobutanol. Now if you go by the alpha beta nomenclature, so carbon 1 is going to be the main functional group. We give the alpha to the carbon next to that. So then this is going to be alpha. And then the carbon bearing the chlorine is going to be your beta. And then the carbon 4 would be gamma, alpha, beta, gamma. So that is called beta-chlorobutyraldehyde. Beta-chlorobutyraldehyde. That's the common name. Okay. And then the next one, we have 1, 2, 3, 4. On the third carbon you have a methyl group, 4 carbon long chain, so there would be 3-methyl-butanol, systematic name. Isovaleraldehyde is the common name. This is not that common. I haven't heard about this much. Isovaleraldehyde. Anyways, if you can figure out the systematic name, that would be good. So then this one has 2 aldehyde groups. So we have how long is the carbon chain? 1, 2, 3, 4, 5, 6. So hexane dial. You don't have to specify where the aldehyde groups because it has to be terminal anyways. So this could be called as hexane dial. And if the aldehyde happen to be on a ring, how do we name it? So this one is considered as a substituent, and this is called as a carb aldehyde. Carb aldehyde. Cyclohexane carbaldehyde. It's considered as a substituent on the carbonyl group, cyclohexane carbaldehyde. And then this one has a benzene ring on the carbon as a substituent. So this would be benzene carbaldehyde. Okay. Okay, so we learned that the aldehydes are going to end in al in the systematic name. Now the ketone, excuse me, for the ketone, it ends as on, this part, O-N-E. So systematic name. So this has 3 carbons. 3 carbons long chain is propane, and the only place that a ketone can be in a 3 carbon chain is the middle carbon. If it happened to be a terminal carbon, then it would become an aldehyde. So the systematic name is propanone. We don't have to call where it located. You don't have to say 2-propanone. It is included when you say propanone because that's the only place a carbonyl group can be. Okay, and the common name is acetone. Everybody knows when you call it as acetone. We have used it even general chemistry 1, 2, and then organic chemistry 1. Acetone is a good solvent also. Okay. Derived name dimethyl ketone. It also has a derived name dimethyl ketone. And then we have this one. It's a how many carbons long? 1, 2, 3, 4, 5, 6 carbons long. And then when you count it, you want to count it such a way that the carbonyl group gets the lowest numbering. So if you go from here, there would be 1, 2, 3. If you come from here, 1, 2, 3, 4. So you go from this side. So 1, 2, 3, 4, 5, 6. So the third carbon carry the carbonyl group. So this is 3-hexanone. Okay. Or it could be called as ethyl propyl ketone, because one side you have an ethyl group and then the other side you have a propyl group and a ketone. Okay, and the groups are named based on the alphabetical order. Ethyl comes before the propyl, ethyl propyl ketone. And then let's see this compound. You start numbering from this side because number 2 gets the ketone. 1, 2, 3, 4, 5, 6. On the 6th carbon you have a methyl group and 7 carbon long chain. So you have a substituent on the 6th carbon that would make it 6-methyl. And then we have to specify where the ketone is. And 2-heptanone. Hept because it's a 7 carbon long chain. 6-methyl 2-heptanone. Or it could be called as isohexyl. This is the isohexyl part, methyl ketone, methyl ketone. Okay. And the carbonyl is assumed to be at the 1 position in cyclic ketones. So this is a cyclic ketone. Carbonyl group is assumed to be the number 1 position. So we can just say cyclohexanone. Doesn't have to say it is 1 or so. And then here you have 2 carbonyl group, and that can be named as butane dione. Since 1, 2, 3, 4, butane dione. Doesn't have to say 2, 3 butane dione because that's the only place the 2 carbonyl groups can be. Okay, and then this is a 5 carbon long chain, and then you have the 2nd and the 4th position ketones or carbonyl groups. 2, 4 pentane dione, 2,4-pentane dione, or acetyl-acetone. Acetyl-acetone is this compound. Okay, because acetyl group is this group, acetyl group. If somebody tells you that's an acetyl group, This is acetyl group. And then the other part, excuse me, and this part is similar to acetone. CH2CO CH3. Only difference is acetone has CH3, but now we have CH2. So because of that, that is acetyl acetone. Okay, and then the next one, we have a carbonyl group and alkene, and then we need to know which one gets the priority. Normally the carbonyl group gets the priority, so we number it such a way the carbonyl will get the lowest number, 1 2 or highest priority, 1 2 3 4 5 6. So in the fourth position we have a double bond, alkene. So it's 6 carbon long chain, so it would be named as 4 hexene 2 on. Fourth position, 1 2 1 2 3 4, 4 hexene 2 on. That's how you would name that. And so in here we had 2 functional groups, so we need to know which one gets a priority. So we have a table that we can find out what is the order of priorities of the functional groups. And then some more ketones that we can learn how to name. And here you have a phenyl substituent on the carbonyl group. Common name is, this is called acetophenone. And then the derived name is methylphenyl ketone. And then this one would be common name butyrophenone. It has 1 2 3 4 carbons, butyrophenone, or phenylpropyl ketone. And this one is called benzophenone or diphenyl ketone. Excuse me. Here's the functional group's priority. If a compound has 2 functional groups, the lower priority group is indicated by its prefix name. Okay, now the suffix name, meaning the main functional group or the one that gets the more priority, will be ended with the suffix name, and then the other would be named as a prefix name. If you have a carboxylic acid, it would be ended as oic acid. Okay, and then the ester would be O8, and prefix would be alkoxycarbonyl, and then the prefix name for the carboxylic acid would be carboxy. Amide, amido. Nitrile, cyano is the prefix name. Aldehyde would be al, suffix name, but if the prefix, if it is considered as a substituent, we would call it as an oxo group. Again, for the aldehyde also, if it is a formyl group like the carbon hydrogen, we can call it as a formyl, coming from the formaldehyde. And ketone main chain would be on. Again, for the ketone also, prefix would be oxo. So you can see for the aldehyde and the ketones both, if they happen to be as a substituent, they both would be called as oxo. Alcohol suffix name all, like pentanol. But if it is a substituent, we will call it as a 2-hydroxy, something like that. And then the amine, amino. Alkene ends in "ene" if it is the main functional group, but if it is happen to be a prefix, it would be alkenyl. Alkyne ends in "ine", substituent alkynyl. Alkane, ane, like for example propane, but if it is supposed to be substituent, then would be propyl or propyl, alkyl. Ether, there is no suffix name for ether, but the prefix would be alkoxy. And the alkyl halides, suffix name not given, but the prefix name would be halo. Okay. naming compounds with two functional groups. Now we can refer to the order when we are trying to name these compounds. So we have alcohol group and an aldehyde group. Which one gets the more priority? Is the aldehyde group. So because of that, aldehyde will get the suffix name. Alcohol would name as with the prefix name as a substituent. So this will get the number 1, 1, 2, 3. So in the third carbon we have an alcohol. And alcohol is given the prefix hydroxy. So 3-hydroxy. Since 1, 2, 3, 4 atoms, 3-hydroxybutanol would be the systematic name. And this one we have a ester group. Carbonyl group OCH3, so this is ester. And then we have a cyano group. So ester gets priority over cyano group. So this will get the suffix name. This would get the prefix name. And when the esters are named, normally you first name the alkyl group on the oxygen. So that is methyl, and then this would end in O8. It has 1, 2, 3. 1, 2, 3 carbons. And on the third carbon you have a cyano group. So methyl 3-cyanopropanate. Methyl is this group. Third carbon has a cyano group. Methyl 3-cyano, and the main chain has 1, 2, 3. 3 carbons. Propanate. Okay. And then this one we have a alcohol group and amine. Alcohol gets the priority, the one on yellow. Okay. So this would be named as a prefix. So you're going to be numbering from here 1, 2, 3, 4. On the third carbon there is a methyl group. And on the fourth carbon there is an amino group. And then when you are naming the substituents, you give the priority to the alphabetical order, not the number. So amine comes before, A comes before M. So even though this is at the fourth carbon, you would say 4-amino, 3-methyl, 2-butanol. 4-amino, this is the fourth carbon. 1, 2, 3, 4. Fourth position you have amino group. Third position you have a methyl group. Second position has an alcohol group. So the OH takes the suffix name because that's the priority according to the priority order. 4-amino, 3-methyl, 2-butanol. Okay. Now this one here, you have an alkene group. You have a carbonyl group. When one group is an alkene, suffix names are used for both. "-ene" is changed to "-n" and stated first. "-ene" is changed to "-n" and stated first. Let's see how to do that. So this one, this is an aldehyde. 1, 2, 3, 4, 5. So on the third carbon you have an alkene group, and then the carbon chain is 5 carbons long. So on the third position we have a alkene. So 3-pentenyl, not pentanal, pentenyl. Te represent the alkene, and aldehyde supposed to be at the first carbon here, and also a terminal carbon. So when it says 3-pentenyl, we know this is an aldehyde, and on the third carbon there is an alkene group. Okay. Excuse me. Here's another example, naming compounds with two functional groups. So here you have an alkene and you have an aldehyde. So if you have an aldehyde and alkene, who gets the priority? You can refer to the table. Normally the aldehyde is going to be more reactive, so it gets the priority. And this would be considered as a substituent. So it will get the prefix. 1, 2, 3, 4. So for oxo, carbonyl group is given the name for the prefix as oxo. So 4-oxo, 5 carbons long, 1, 2, 3, 4, 5, 4-oxopentanal, since it's an aldehyde. And then this one is an ester. Okay. So ester, this is the alkyl group on ester. So this would be methyl. You first name the methyl, and then 1, 2, 3, 4 carbon long. On the third carbon there is a oxo group, so it would be 3 oxo. So the third carbon, it would be 1, 2, 3, 4. So 3 oxo butanoate. Ester ends in O8. Methyl is this methyl. 3 oxo butanoate. Okay. And then here you have an amide group and aldehyde group. 5 oxo pentanamide. So the amide group takes 5 oxo pentanamide. So 1, 2, 3, 4, 5. So the fifth position you have a carbonyl group, that's 5 oxo, and then this is 5 carbon long pentanamide. So the amide group named at the end as the suffix, and this group considered as the prefix, oxo group. Okay, so let's stop this section here, and then we'll talk more into detail how the reactions takes place in these carbonyl compounds.